Sure. Hey, why not? Yeah, let's talk about this. All right, so for 2 folds, how many sections did you have? 4. And so what was the area of each section compared? Oh, Grace, I got your name again. It's your lucky day. Yeah, 1/4. Perfect. Just not here. Hayden, how many sections did you get with 3?
8.
And so what was my area?
28.
Huh?
28.
Oh, I thought you said 28, and I was like, huh? All right, Kaylee, how many did you get for 4? Actually, let's save you for 7.
Well, you also messed up on the times.
What is it?
It's not 8 at the top.
Good.
Wait, I'm just confused on that.
No, it's not.
Did you count your sections, or were you just too intent on getting 7 folds? Huh? It's all good. All right, so if I folded it 4 times, how many did I have? Chris, what'd you get? 16. And so your area was, all right, then Annie, what was 5? And so your area was 1/32. Okay, who had 6? All right, what'd you get for 6? All right, so your area was, all right, Kaylee, how many did you get at 7? Okay, so your area would have been 128. Perfect. Okay, so we have the definition of a function is that for every one input, there's an output, a separate output, right? Okay, so we're looking at the folds to the sections. Why is that a function? Anybody? Why would that be a function? All right, Chris.
There's a singular y for each class, right?
Yeah, because it is the definition. It is there. There is 1y for each x, which is the definition of a function. That's just a, hey, go back and justify your function again. Okay, so what's the domain? First question, what is domain in general? Oh, Grace, it is your lucky day. Yeah, so it's your x values, right? It's where you start in the x values. So, Chase, what's the domain of your function?
5.
You went up to 5, yes.
Oh, I went to 6.
You went to 6. So how would you express your domain? Is 2 in your domain? Okay, is 4? Okay, so is 0? So is -1? Okay, so we started at 0, and we went to, how many did you go to? So yours would be to 6. Kaylee and mine could be to 7. If you only went to 5, then yours is 5. So it's all going to depend on what you individually did. Okay? All right, so my horizontal is the folds. My vertical is the sections. Okay, and here's my origin. So let's plot the points. Now, my folds are the x, and my y's are my sections, so I'm going to have like 0, 1, and 1, 2, and 2, 4, right? Okay, so 0. I should probably put my glasses on so I can actually do this correctly. So there's 0, 1. There is 1, 2. There's 2, 4. Then I have 3, 8. And then I have 4, 16. 5 is going to be like up here in the table, right? Because it's 32. It's off the chart. Okay. All right. So do I want to connect these points with a smooth curve? What do you think? Jacob, why do you say why? Yes. Because it makes it a smooth curve, okay? But the other thing too is it a function? If it's a function, since it's a function, it includes all of the little points in between, okay? Not just this, so it includes these points here. Includes all the points. So we use the smooth curve. Okay, because technically I could say x is 2.5. And so my graph's going to show that point if I draw a smooth line. Does that make sense? All right, anybody come up with a function equation? This is a tricky part. Yes? No? I saw some people writing stuff. Erin, did you come up with one? You came up with the y-intercept. What's my y-intercept?
1.
Okay, I'll agree with that. B's going to be 1. What type of graph is this? Is it linear? No, it's not. What type of graph do you think this is? It's exponential. That's what we've been talking about, right? And we know that exponentials go up because it increases rapidly, right? And so we know it's increasing. All right, let's look at our values up here, okay? What were we doing between everything, between each of the y's? How did we get from 2 to 4? What could you do? Times by 2. And if I went from 8 to 16, what could I do? Times by 2. So, and since exponentials, so we have a multiplier of 2. Would you agree with that? Okay, so let's think about this. Isn't this the same as 2 to the first? And isn't this the same as 2 second? And this is 2 cubed. And then we have 2 to the fourth. Okay, do you see a pattern here? What would our base be? Yeah, so our base is going to be 2. My x is the number of folds. And, Erin, what was our y-intercept? Plus 1. Perfect. Okay. Now, if Kaylee became a strong superwoman and could actually get 15 folds, how many sections would the paper have? Well, now I can use my equation, say 2 to the 15 plus 1. Anybody know what 2 to the 15th is? That's a calculator one. Anybody got the calculator handy? I'll make you know 2 to the 4th and 2 to the 5th, but 2 to the 15th, no. That's one we can defer to the calculator.
32,068.
32,000. 768 plus 1 gives me 769. That's a lot of little itty bitty areas. Okay? Good?